Okay, hi everyone again. I'm pleased to be here, and it's very great to present this work entitled Determination of Selection Criteria for Wave Energy Converters. Actually, this was authored by me, Sertap, my friend Hasan Suat, and our precious advisor, Associate Professor Irem Ucal. Actually, me and my friend Hasan, we are undergraduate senior, as I said, at Istanbul Technical University in Industrial Engineering Department. And this is my agenda for today, for my presentation. And I will start with introduction, with explaining our motivation behind this study. Then I will continue with our literature review, our objectives, methodology and analysis, and I will finish with conclusion. Actually, one of the most direct indicators of the development and well-being of society is the amount of energy usage. And the amount of energy consumed globally more than doubled throughout the 20th century, with much of it coming from coal, oil, and nuclear power for electricity. And in this context, renewable energy plays a key role, and the advantages of renewable energy for the environment and economy are enormous, because they are renewable sources, so they don't run out over time. They are many and diverse worldwide, and for that reason, if renewable energy sources are correctly utilized, they might potentially offer energy security for nations all over the world, and they reduce greenhouse gas emissions and assist in addressing global warming, which is one of the major issues of the 21st century. And there is also a global trend toward using more renewable energy sources, and it is anticipated that in the next decades, their percentage of the world's power production will rise. And significant progress has been achieved in the development of solar and wind energy generation, as we know, and they are important sources of renewable energy. And but there's another energy source with a huge potential that is rapidly emerging and piquing the scientific community's attention. It is wave energy. Actual wave energy is created from wind, and wind generated by solar energy sweeps over the water and transforms it into waves. And with minimal energy loss, this wave energy can move hundreds of kilometers. And most crucially, unlike wind or solar energy, waves are a consistent source of electricity, and its intensity can be precisely estimated days in advance of its appearance. And wave energy is one of the most prevalent sources of energy on Earth, because it has unquestionably shown to be the cleanest, most reliable, and most anticipated energy source. And it has the potential to rival the utilization of non-renewable energy sources when in use. And by bringing new technology to the renewable globe, recent research on the wave energy creation has created a new perspective to gradually decrease the dependence on fossil fuels. But it is rather inadequate in the economical aspect right now. And in this context, this study aims to determine the criteria weights to select the most suitable wave energy converter to produce wave energy efficiently. So we decided to scanning the literature regarding this, and we found that the oceans have a massive amount of energy potential. A thorough examination of the literature revealed that actually 93,000 terawatt-hour potentials for various wave energy sources. And it turned out wave energy is one of the most significant untapped renewable energy source. And the necessity to bring this technology up to par with existing fossil fuel-based power plants is driving the rapid growth in wave energy converter technologies. And since their first patent in 1799 by a father and son called Girard, the number of wave-powered device prototypes has climbed about 1,000, but actually only a few hundred of these have progressed to the model testing stage. So it is possible to collect wave energy converter devices under 3 categories. And it's a commonly accessible energy source since it has multiple size from coastline to deep oceans. And as I said, converters have been classified in 3 groups. First one is location. There are 3 sorts of converters according to their distance from the coast: onshore, nearshore, and offshore devices. And wave energy converters classed as follows based on their size and orientation with respect to the oncoming wave. And finally, they are categorized for their working principle. Actually, one of the most well-known wave energy extraction concept is oscillating water column. And this approach makes use of the oscillating wave principle, which is created by the rise and fall of pressure inside the capturing chamber. And as an hypothesis, our research question is it possible to find a cleaner and more sustainable energy source in order to overcome energy cuts and problems in electricity distribution with the increasing energy need today? And our aim is measuring the ways of the criteria to compare wave energy conversion technology alternatives in order to achieve energy sustainability goal. And we try to answer this question by applying analytic hierarchy process, which is called AHP method, for measuring the ways of 3 main and 8 sub-criteria, which I will explain in the next slides. And regarding the methodology that we use for the problem, it's a 3-phase methodology. First of all, we developed the decision-making model based on literature review, experts' opinion, and regulations. Then we decide to collect pairwise comparisons for the AHP method. And finally, we implemented AHP method to prioritize the criteria and sub-criteria. And while regarding the data model and analysis, we have a complete decision-making model with 3 criteria and 8 sub-criteria, as I told. And among the criteria, we added environmental criteria, includes sub-criteria as impact on ecosystem and land requirements, and economical criteria with investment costs, land costs, and operation and maintenance costs. And lastly, technical criteria with energy capacity, efficiency, and distance to transmission lines. And 3 decision makers participated for the model. They have different backgrounds, actually, and 2 of them are working as an engineer and manager in energy sector, and the other one is working on that area as academician. And we use comparison scale for making decisions. For example, if decision maker thinks economical and technical criteria are equally important, they give 1. And if they believe that economical criteria are definitely important compared to technical one, they give 9. And we found their weights with finding their normalized matrix first and then taking their averages. You can see their local weights. It means their importance in their own groups. But when we want to find their importance within all groups, we multiply main criteria weights with local weights. And as a result, we can see here the environmental factors are the most important criteria, followed by economic factors and technical factors. And in the future work, me and my friend Hasan, actually we are doing this enlarged project for our bachelor thesis. And we will try to make a decision for wave energy converter considering these weights of criteria. And this is the end of my presentation. And thanks for your attention. If you have any questions or comments, I'm ready to respond.
Okay,
thank you.
Thank you very much for your presentation. Is there anybody in this room that would like to ask questions to the presenter? Okay, so again, me. There are several questions I would like to ask you. You are doing your bachelor degree, right?
Yes, it's correct.
Your final bachelor degree thesis. Okay, so several questions. First of all, when you said that you found the criteria in a literature review, right?
Yes, it is true.
There is specific literature review for this type of energy source, or you use general literature review? Because as I see here, that's the slide I wanted to see. Your criteria are not very specific for this energy source. They are very general. They would be useful for any type of energy source, right? So my question is, would you also use this model for other energy sources?
Actually, in my opinion, like you said, we can use some of these criteria for another energy source like wind or solar energy. Actually, in our literature, we try to read some papers about both renewable energy and both for wave energy. And for example, in technical one, we can see distance transmission lines. For example, it was from a paper about wave energy, but like you said, we took some of them from the renewable energy papers.
Okay.
It is both, I can say.
Okay. Then on a particular question, C12 land cost, that means how much the lands where you are going. Sorry, I don't understand this because waves are in the sea. So what's the land you need?
Actual land cost means, for example, we will use some places for using that energy converters. For example, some place in Turkey near the agency. So we need to maybe actually, how can I say?
You should buy the lands to install that equipment, the fee of the land.
But these lands, Ilker, that you buy, are they near the sea? Is it possible to buy the land?
This is Turkey.
Yeah. Because I was wondering, as soon as I saw land cost, I say, what? So are you buying the land? It's near the sea? Is it everything is to sale or what?
I just guess. I'm not sure about.
Actually, we talk about the same idea.
Okay. So, okay, thank you. Another recommendation, when you present the results, sorry, Sertap, I cannot pronounce. Before that, the one before.
That.
Okay. Yeah, it is not necessary to present so many decimals, okay? Just with two would be enough because they are not significant, you know?
And it's hard to read,
Yeah, so it makes no sense. I mean, the results are okay, but do not show so many decimals, just two of them, 0.52 or 5 in this case, 5.3, whatever the rounding is, okay? So that's it.
Okay, I will consider.
Yeah, okay. For my side, there are no more questions. Any other questions?